Are you interested in knowing about the top 5 most secret military aircrafts? Have you ever heard anything about them? If you haven't, then you should stick till the end of this video as we unveil the top 5 secret military aircrafts and what engines and everything there is to know about them. Without further ado, let's get back to the video. Number 1. SR-72 and Project Mayhem. Its predecessor, the SR-71, was launched on April 15, 1986. There was one aircraft capable of making such a daring flight. Pilots called it the Habu, the Pit Viper, but most of the world called it the SR-71 Blackbird. Lockheed Martin developed the SR-71 as a black project under supreme secrecy, and it was engineered around a simple concept. Nothing could shoot you down if it couldn't catch you. The Blackbird's top speed, Mach 3.2, set new records for jet engine aircraft. But on a pre-established flight path against Libyan surface-to-air missiles, thought to be Soviet-designed SA-2s and SA-4s, capable of Mach 5 speeds, it would need to push past its limits. By 2015, the SR-72 was no longer hidden behind a black project veil. Its page on Lockheed Martin's website advertised that it could be in service by 2030. Up until March of 2018, Lockheed was public about its efforts to field the SR-72. But immediately after Putin's speech announcing the Kinzhal, the company redacted any outward-facing mention of the plane, either because it gave up on the effort or because it was pushed back into the shadowy world of projects using classified funding. Further, it appears that the military is developing a new type of engine to propel the SR-72. As NASA has learned through years of experimental testing, a traditional scramjet engine wouldn't meet the needs of Project Mayhem's multi-mission purpose, as scramjets function only at high speeds. Instead, Lockheed Martin appears to be developing a combined cycle scramjet that incorporates a traditional jet engine into its design. An engine of that type would be a massive leap forward from what's available now and require sophisticated engineering to solve the many design challenges. It's likely what's holding the project back. This system would use the traditional jet engine to take off and accelerate to around Mach 3 before transitioning to a scramjet that will launch it beyond Mach 5. At speeds of Mach 5 and above, aerodynamic heating creates temperatures hot enough to melt conventional metallic airframes, so engineers are considering composites such as high-performance carbon, ceramic, and metal mixes for the fabrication of critical components. Such composites have been used in intercontinental ballistic missiles and the retired space shuttle. Number 2. NGAD. The Next Generation Air Dominance is a United States Air Force 6th generation fighter initiative with the goal of fielding a family of systems that's to eventually supersede the Lockheed Martin F-22 Raptor. A manned fighter aircraft is the centerpiece program of the initiative and has been referred to as the FX, or Penetrating Counter-Air, and is to be supported by unmanned loyal wingman platforms. The NGAD was initiated in 2014 to develop a 2030s air superiority system for the U.S. Air Force. DARPA completed its Air Dominance Initiative study in March 2014 and in 2015 launched the Aerospace Innovation Initiative to develop X-plane prototypes to demonstrate technology for future aircraft. In 2016, the U.S. Air Force followed up DARPA's study with the Air Superiority 2030 Flight Plan. But while the plan stated the need for a family of systems, it was still focused on a specific member of the family called the FX, or Penetrating Counter-Air. In 2018, the program expanded its focus from a single edition towards a suite of capabilities. The NGAD aims to develop several key technologies in areas such as propulsion, stealth, advanced weapons, digital design, CAD-based engineering, and thermal management of the aircraft signature. The program changes traditional Air Force acquisition by the separation of design, production, and support functions in the development process with a $9 billion budget through 2025. More frequent industry competitions and simulations in the design and manufacturing process are characteristic of the development program. NGAD is described as a family of systems, with a fighter aircraft as the centerpiece of the system, and other parts of the system likely to be unmanned escort aircraft to carry extra munitions and perform other missions. In particular, NGAD aims to develop a system that addresses the operation needs of the Pacific Theater of Operations, where current USAF fighters lack sufficient range and payload. USAF commanders have noted that there may be two variants of NGAD, one with long range and payload for the Indo-Pacific, and one more oriented to the relatively short ranges between possible battle areas in Europe. The fighter is expected to leverage adaptive cycle engines being developed under the Adaptive Engine Transition Program and next-generation Adaptive Propulsion Program, with flight-ready engines expected by 2025. Number 3. X-37B. The U.S. Air Force's unmanned X-37B spaceplane has flown 4 clandestine missions to date, carrying secret payloads on long-duration flights in Earth orbit. The robotic vehicle resembles NASA's famous Space Shuttle, but is much smaller. The X-37B is about 29 feet, 8.8 meters long, and 9.5 feet, 2.9 meters tall, with a wingspan of just less than 15 feet, 4.6 meters. At launch, it weighs 11,000 pounds, 4,990 kilograms. The X-37 is currently run by the U.S. Space Force, but up until 2019, it was run by the Air Force Space Command and used for covert missions and orbital spaceflight missions meant to showcase reusable space capabilities. It's a variant of the previous Boeing X-40 that's been scaled down by 120%. Before being turned over to the Pentagon's Defense Advanced Research Projects Agency in 2004, the X-37 was a NASA project. Development began in 1999 when NASA chose Boeing Integrated Defense Systems to create and construct an orbital vehicle. This was then made by Boeing's Phantom Works in California. Despite flying 6 missions to date, the X-37B's true purpose remains a mystery. Understandably, the Space Force's latest orbital test vehicle drone has drawn some suspicion from home and abroad with regard to its actual purpose. Is it a space-based anti-satellite strike aircraft? Is it used for high-altitude surveillance and the deployment of spy satellites? According to the Pentagon, the X-37B was recently fitted with a new service module that allowed for large numbers of experiments to be carried to orbit. During a 2020 mission, the X-37B deployed a small satellite called 𝒂𝒂𝒐𝒎𝒆, which contained 5 experimental payloads designed by NASA and the U.S. Air Force. This was the first time the military had disclosed any specifics about such cargo. The X-37 is principally used for space exploration, risk reduction, and developing reusable space vehicle technologies. It's derived from the X-40A spaceflight and is one of the most modern spacecraft in the world. Fueled with military-fueled JP-8 and hydrogen peroxide, the Rocketdyne engine of the X-37 is designed to run for 9 months. The engine installed in the aircraft currently uses hypergolic nitrogen tetroxide or hydrazine. Number 4. RQ-180. After the retirement of the SR-71 Blackbird in 1999, the U.S. Air Force lacked an intelligence platform capable of penetrating airspace guarded by advanced air defense systems. The RQ-180 was designed to fulfill the mission previously accomplished by the high-speed SR-71. The RQ-180 appears to be a follow-on to the Joint Unmanned Combat Air Systems project, which was cancelled in late 2005 when the United States Navy wanted a carrier-based aircraft, which led to the US ACD, while the United States Air Force wanted a larger, long-range global strike platform. In December 2005, the program was split in two, with the USN starting the UCASD program, which created the Northrop Grumman X-47B, and the USAF starting a classified program. The program was unmasked in Aviation Week and Space Technology in a December 9, 2013 cover story following several months of research. The RQ-180 was secretly funded through the USAF's classified budget. Northrop Grumman was given the task to build the aircraft after a competition in which it defeated Boeing and Lockheed Martin. Northrop Grumman is believed to have been awarded a development contract for the RQ-180 in 2008, with deliveries of low-rate production aircraft beginning in 2013. Satellite imagery of Area 51 reportedly shows large hangars that could house the 130 feet, 40-meter or larger wingspan of the aircraft. The 𝒄-180 may also be related to the expansion of Northrop Grumman's production facility at United States Air Force Plant 42 in Palmdale, California. According to Aviation Week, the secret development of the 𝒄-180 explains public statements of USAF officials calling for penetrating intelligence, surveillance, and reconnaissance capabilities with no public acknowledgement of an effort to create one. It may explain the service's lack of commitment to the 𝒄-4 Global Hawk and instead favoring of higher priority classified platforms. The USAF also doesn't want to buy and maintain large numbers of MQ-1 Predator and MQ-9 Reaper systems in order to have an aircraft that would have the ability to penetrate denied airspace and persistently provide ISR coverage. The 𝒄-180 may also be responsible for the termination of the Next Generation Bomber program in 2009 from costs, and the emergence of the follow-on Long-Range Strike Bomber program that will be cheaper and work with the UAV. The USAF MQ-X program that was to find a platform to replace the Reaper may have been cancelled in 2012 because of the 𝒄-180. The creation of the 𝒄-180 is believed to be related to the LRS-B program, which will have a new strategic bomber operate with a family of systems, including a long-range standoff weapon, conventional prompt global strike missiles, and electronic attack and ISR platforms. The 𝒄-180 would appear to fill the electronic attack and ISR roles. On October 27, 2015, the LRS-B development contract was also awarded to Northrop Grumman. Number 5. GJ-11. Hongdu GJ-11 Sharp Sword is a stealth unmanned combat aerial vehicle, jointly designed by Shenyang Aircraft Design Institute, Shenyang Aerospace University, and Hongdu Aviation Industry Group. Manufactured by Hongdu, it descends from the AVIC 601S program, being one of the proofs of concept design winners. The Sharp Sword is powered by a single turbofan engine and has a flying wing design with a wingspan of 14 meters, 46 feet, featuring an internal weapons bay and a stealthy propelling nozzle. The precise mission to which the Sharp Sword has been assigned is not yet known, but possible missions include aerial reconnaissance and eventually combat missions. On November 21, 2013, a Sharp Sword conducted a 20-minute maiden flight from Hague's airfield. In October 2021, the Aviation Industry Corp of China showcased the GJ-11 at Airshow China. The drone is reportedly capable of taking off autonomously from Type 075 amphibious assault ships. The stealthy drone could deploy swarming air-launch decoys or electronic warfare systems, in addition to launching precision-guided munitions. A stealthy armed drone such as this, able to carry and fire glide bombs or precision strike air-to-ground missiles, may not yet have an operational US equivalent, despite appearing to be modeled after several US stealthy aircraft designs. The new Chinese GJ-11 might bring a rare blend of attributes not likely to be matched by other countries. Many countries have armed stealth fighters, but for most countries, armed stealth drones have not fully emerged. Made by a Chinese company called AVIC, the GJ-11 is reported by the Global Times as having 2 weapons bays between the drone's landing gear. Each bay, the report says, has 4 bomb locations and what appear to be guided precision air-to-ground bombs. That's it for the video. If you enjoyed it, kindly like the video and subscribe to our channel.